So, Rixson 117-3/4, and your question is, and thank you for the question, building a steel frame for my door. You're building a frame for the door, and I'm having all glass in between the door. Does the bottom and top arms have to be flush with the material of steel I'll be using? I assume we can weld the arms on. I imagine I would have to cut into the steel at the correct depth and length for the arms to sit flush. Am I on the right track? So, it seems like you're building a steel perimeter for the door. And even if you're not, no big deal. Whatever the construction's going to be. So first of all, the 117-3/4, or the 117-3/4 is a center hung pivot. So do the top and bottom arms have to be flush? Well, the top pivot needs to be flush with the top of the door. There's no reason that you would have it recessed in or projecting on top of the door. That would be flush. Now, the bottom arm, however, is a different animal altogether. And when you look at the link to the template for the 117-3/4, you're going to see, let's pull that up, that where you place the bottom arm is directly related to the undercut. So there is a link in this answer to that template, or installation instructions they call it. Now you can certainly make it flush, and you can weld them on if you want, but I would very much not recommend welding them on, because sooner or later you're going to need to service this pivot, and it's going to be tough for whoever inherits the door and frame to have to service the bottom bearing in 10 years if that ever becomes something necessary. I would dissuade you from welding it. Not only am I not confident in the base material of the hardware to be welded to the structure, but since you're dealing with steel, you can easily fabricate yourself some mounting tabs, and you will make some offset Z brackets, bent offset to whatever dimension and depth you need for the hardware according to the template, and the undercut, you'll drill and tap that those mounting brackets appropriately for the fasteners as included, and you're going to make it so that it can be removed. That would be the way to go. Since you can obviously cut and weld, you're going to want to just make some mounting brackets. Custom hollow metal door manufacturers, if you're making this, if they were making it for this, they would do exactly that. Now, if you look at the installation instructions, on the lower right-hand area on the first page is where exactly you're going to see the relationship between the depth of the arm where it's mortised and the undercut. And as you study that, you will see that when you increase the undercut, you decrease the amount that the arm is mortised into the bottom channel, the bottom rail of the door. So if you wanted the minimum undercut, which is 3/16 of an inch, your mortise would be 1 1/16 deep. So you're going to create an inverted channel that's 1 1/16 deep from the bottom of the door to bring the arm up into, and then drill it, attach it with the machine screws that would come with it to that. Now, if you look at the chart immediately to the right of that, door mortised deep for arm, you can see how the depth needs to change when your undercut changes. So let's take an example here. If you were to change the depth, if you wanted to increase your undercut from 3/16 of an inch to something greater, let's say that you were going to incorporate a 1/4 inch threshold. What the factory is telling us is that your depth of mortise is going to be 7/8 of an inch. You are then still going to have 3/16 of an inch, but you're going to have then below that 3/16 a 1/4 inch. Now that is 7/16 of an inch and does not add up to the difference between 7/8 and 1/16. But what they're doing is accounting for the fact that you want 3/16 of an inch from the bottom of the door to the top of whatever you are applying, to whatever the top of the floor surface will be. And what they're really doing in that table is basically just telling you how deep to mortise the arm based on what the condition will be at the floor. So if you were to look at the technical drawing and notice the size of the arm, the thickness of the arm, at the spindle, it's 5/8 of an inch. And if you were to calculate the relationship between 1 1/16 deep mortise for the arm equaling a 3/16 of an inch dimension from the top of the floor plate to the bottom of the door, you can then basically decrease the depth of the mortise for the arm as you increase the undercut. And there would be a direct relationship to that. So how much room do you want below the bottom of the door to the top of the floor plate? Calculate that against the standard 1 1/16 depth deep for the bottom arm. Be mindful on the 117-3/4, because of the weight that it's rated for, 600 pounds, you see that those are lugs, hexagon concrete anchor measures, etc., etc. Those are not screw holes. Those are lugs that are coming off. There are 4 of them on the bottom side of the body because that pivot is designed, because of the weight it can handle, to be placed into a grout-filled cavity. There's no screwing of this to the floor. Now, I've had people do it. They've literally cut those hex lugs off and drilled in countersunk through the base and then attached it to the floor, but it's not engineered for that at all. To hit the weight capacity of 600 pounds, got to set that thing in concrete. Something, just as an aside, something that people don't really get into. Any other follow-up questions, don't hesitate to ask, and thank you.